In this video, we will generate the dataset of the Erlang distribution over the values from 0 to 6 of x, and our alpha will be from 1 to 3. So data validation for alpha, list of items from 1 to 3. Likewise for beta, we can start with 1 with alpha. And for beta, so data validation, list of items, also from 1 to 3. We can start with 1. And the GAMMADIST is equal to array formula GAMMADIST that's GAMMADIST of the x values. For value of alpha, the shape is 1, the rate for beta, and 0 because this is the probability density function. Likewise, the Erlang distribution. So this is array formula. The first part is x raised to the power alpha minus 1. So x raised to the power the quantity alpha minus 1. That's the first part. The second part, e to the power minus x over beta. So exponent minus x raised to the power, that's over beta. So that's over beta. So that is e raised to the power minus x over beta. We completed the numerator. Now the denominator. The denominator has two parts, beta raised to the power alpha. So the quantity beta raised to the power alpha. That's the first part. The second part. The second part is factorial alpha minus 1. So factorial alpha minus 1. Then enter. These values are exactly the same because it's GAMMADIST for integer values of alpha. The GAMMADIST and the Erlang distribution are the same. Now we continue with the Taylor series expansion, which is the summation of a times x to the power alpha minus 1 plus n, where our n is from 0 to infinity. And our value of a is negative 1 over gamma alpha times beta raised to the power alpha plus n times factorial of n. So this is our formula, minus 1 raised to the power n. That's the first part. The second part, the denominator. There are three parts of the denominator. First part is gamma of alpha. So gamma of alpha. That's the first part. The second part, beta raised to the power alpha plus n. So beta raised to the power the quantity alpha plus n. Alpha plus n. That's the second part. And finally, the third part. The third part is factorial n. Factorial of n. And enter. Now we can complete the Taylor series expansion. Our formula, series sum of the x values. So the x values raised to the power alpha minus 1 plus n. Alpha minus 1 plus n begins with alpha minus 1. So alpha minus 1. And the increment is n. The increment of n, 0, 1, 2, 3. So the increment is 1. And the coefficient a. This is the coefficient a. So this will be the coefficient a. Then enter. So this approximates GAMMADIST and the Erlang distribution. We chart this. So insert chart. And we use scatter chart. Use column as label. We delete this, we don't the title because we have the label, the equation as label. For the series, show the trend line. The type, polynomial. The degree, 6. For the label, use the equation. And for the legend, position at the bottom. So here we have the trend line and the polynomial of the gamma distribution and the Erlang distribution and the Taylor series expansion of both. Next, we calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix, starting with the power. Transpose 0 to 6. The elements of the LINEST matrix is equal to array formula of the x values raised to the power 0 to 6. Now we can calculate the polynomial regression coefficient using LINEST, starting with the GAMMADIST, data y and data x. Again, LINEST, data y and data x. And finally, the Taylor series expansion. This will be LINEST, data y and data x. We compare the polynomial regression coefficients with the chart. X to the 0, 1. Coefficient of x, minus 0.987. Coefficient of x squared, 0.466. It's 0.466. Coefficient of x cubed, minus 0.131. Coefficient of x to the fourth, negative 0.0226 or positive 0.0226. Coefficient of x to the fifth, minus 2.17 times 10 to the minus 3. And coefficient of x to the sixth, 8.86 times 10 to the minus 5. There's an error, 8.9 times 10 to the minus 5. Next, we continue with the beta equals 2. Beta equals 3. Again, we go back to alpha, set alpha equals 2, and our beta starting from 1. Then continue with 2, and continue with 3. And our alpha equals 3, starting at beta equals 1, 2, and 3. This completes the use of the Taylor series expansion, SERIESSUM, LINEST polynomial regression, and the GAMMADIST to show the difference with the Erlang distribution. So the Erlang distribution is the same as the gamma distribution for integer values of alpha.